A truth table is used to describe the relationships of inputs and outputs of a logic circuit in a tabular or table format. A Boolean expression can be used to describe the relationships of inputs and outputs in mathematical form and can be used as a convenient method of describing how a logic circuit functions. In electronics, there is often a need to translate data in a truth table to a Boolean expression. Nevertheless, the logical circuit that can be derived from a truth table may not always be apparent. However, using a form of a Boolean expression called the sum of products, or SOP, designing a logical circuit from a truth table can be easily accomplished. To demonstrate the use of SOP to convert a truth table to a logical Boolean expression, let's look at a 3-input truth table with input A, B, and C, and output Y. Given 3 inputs, there will be 8 possible logical combinations. Sum of products expressions can be generated by examining the truth table. For any rows where the output is 1 or high, write a Boolean product term that would equal a value of 1 given those input conditions. Thus, in the first row, where A, B, and C are all zeros, the product term would be not C, not B, and not A, since that term would have a value of 1 if and only if A equals 0, B equals 0, and C equals 0. The next instance of a logical 1 output is row 2. Applying the same method, the product term would be not C, not B, and A. Continue down the table until all product terms for possible logical 1 outputs have been created. Row 4 is then not C, B, and A. Row 5 is C, not B, and not A. And finally, row 7 is C, B, and not A. The last step is to place all the combinations in an equation to form the Boolean expression for this truth table.